Hello and welcome to lesson 16. I'm sure you've got everything that you need ready for this lesson. So you'll need some pen and paper again, your work from the previous lesson, and if you've been using a multiplication square to help you make some links between your times tables and the highest common factor and thinking about our language of multiples and factors, then perhaps you could have that to hand as well. So get everything you need and I'll see you in a moment. In the last lesson, Mrs. Hussain left you with some calculations to solve and she asked you to give the answer in its simplest form. I'd like us just to think about the generalisation you used to help you do those. So, do you remember this one? Let's say it together. When adding fractions with the same denominator, just add the numerators. Did that really help you with your independent task? Let's try the first one. So 5 1/12 plus 5 1/12 is equivalent to how many 12s? What did you do? Did you say that was the same as 10 12s? Really well done. Why did you say it was the same as 10 1/12? That's right. It's because our unit is 1/12. So we're counting in 1/12. So if we have 5 1/12 and we add another 5 1/12, we've got 10 12s altogether. Now there's another equal sign there. So did you go further and get that simplified? What do I have to do to simplify it? So I need to find the highest common factor, don't I? Can we see that quite quickly? I'm looking at it, I'm seeing that they're both even numbers, so I know that I've got a common factor of 2 straight away. Is that the highest common factor though? No, they're not. I can't find a higher one. I looked at 3, but of course 10 isn't a multiple of 3. Brilliant, so it must be 2. So what do I need to do? I can multiply or divide. So we're going to divide the numerator and denominator by the same highest common factor, which is 2. Brilliant, did you do that? And therefore 10 divided by 2 is 5 and 12 divided by 2 is 6. So your answer should have been 5 6. And 10 12s and 5 6 are equivalent fractions, so they would take up the same proportion of the whole, and that has been expressed in its simplest form. Excellent. Did you do the same with the next ones? So we've got 7 16ths and 5 16ths. So our unit is 1/16. So 7 1/16 plus 5 1/16 is the same as 12 1/16. Fantastic. Now again, how are we going to find the highest common factor of these? I can see that they're both even. So I know that 12 and 16 are in the 2 times tables. Are there any others? Is that the highest common factor? No, that's right. 4 is a common factor of those because 12 is divisible by 4 and 16 is also divisible by 4. So both the numerator and denominator are in the 4 times tables and both have a factor of 4. So I can divide the numerator and the denominator by the same common factor, and the highest common factor will get me the simplest form. So 12 divided by 4 is 3, well done, and 16 divided by 4 is 4. Fantastic. And so that's expressed in its simplest form. Well done. How did you get on with the next one? Let's have a see. So our unit is 1/15. So 4 1/15 plus 2 1/15 is the same as 6 1/15. Excellent. And can we simplify that? Do you think there's a common factor between those two? Can you see that? So 1 is a common factor. Is 2 a common factor this time? No, it isn't, is it? Because 15 isn't even. 3 is 3 a common? Yes, it is. 3 is a common factor because they're both divisible by 3. So 6 and 15 are in the 3 times tables. Is that the highest common factor? Yes. So we can divide the numerator and the denominator by 3. And so our simplest form becomes 2/5. Really well done. And 2/5 and 6/15 are equivalent fractions because they're the same proportion of the whole. And that proportional relationship between the numerator and denominator is maintained as well, isn't it? And then you had a challenge and you were asked to have a look at a subtraction. How did you get on with that? Did you find that you could use the same generalisation because your unit was the same, so you could subtract the numerators? So 8/9 subtract 2 1/9 is the same as 6/9. Well done. Now, there's is there a highest common factor between the numerator and denominator there? Yes, that was quite easy to see, isn't it? They're both divisible by 3. So 3 is a factor of the numerator and 3 is a factor of the denominator. So I can divide the numerator and the denominator by the same common factor, which is the highest common factor. And I get 6 divided by 3 is 2 and 9 divided by 3 is 3. So 2/3 is the simplest form. Excellent. Well done if you got all those correct. So we're going to continue thinking about the simplest form today and calculating, but we're just going to look at one other aspect of that. You were really confident in your practice activity then at calculating with fractions and expressing them in the simplest form. So we're going to continue with that, but I also want us to think back to some terminology that you know of mixed numbers and improper fractions. And we're also maybe going to investigate whether they can be expressed in their simplest form too. Firstly though, have a look at this bar. Can you tell me how many equal parts the whole has been divided into? That's right, it's been divided into 10 equal parts. Fantastic. And what would one of those equal parts be? It would be 1/10. What about this second bar? How many tenths are represented by the yellow portion? Yes, they're 3/10. So we can say, can't we? Let's say this together. The whole is divided into 10 equal parts. One part represents 1/10 of the whole, so 3 parts represents 3/10 of the whole. Really well done. If I show you a bar now, can you tell me how many tenths are represented by the yellow portion? How many tenths are represented there? 6/10. Well done. How many more tenths is that than 3/10? How many more tenths is it? So if we were counting in tenths, how many more tenths would we need? 3 more tenths. Can we express that in a calculation like we were in the last session? Do you think you could write that down now? Pause now and tell me how many tenths I have altogether using an addition calculation. How did you get on? Did you say that 3/10 plus 3/10 is the same as 6 1/10? Excellent, well done. I'm going to show you another bar now. I'd like you to tell me how many tenths there are altogether, but could you write it as a calculation? So pause me now, I'm going to put the bar up and write that as a calculation. How did you get on? How many tenths did you say there were altogether? 9 1/10. What calculation did you write? So I've got 3 1/10 plus another 3 1/10 is the same. Oh, and another 3 1/10 is the same as 9/10. So we've got 3/10 added to 3/10 added to another 3/10 is 9/10. Have I got a whole yet? No, it's less than a whole, isn't it? How many more tenths would I need to make one whole? I would need 1 more tenth, wouldn't I? Okay, I've got a little bit of a challenge for you here. Do you think that you could add another 3/10 to this calculation, but also represent it pictorially? So I want you to pause me, draw bars that represent pictorially how many tenths you have altogether, and write me the calculation. Pause me now. How did you get on? That was quite a challenge actually. So we said, didn't we, that 3/10 plus another 3/10 plus another 3/10 was the same as 9/10. What did you have for your pictorial representation? Did you have something like this? Yes, excellent. So we had to have 2 bars, didn't we? Why have we got to have 2 wholes now? Why have we got to have 2 wholes? Because I needed 3 more tenths. Well done. Did you write this calculation? Excellent. Let's have a look. 3/10 plus another 3/10 plus another 3 1/10. And now I need 3 more 1/10, don't I? 1, 2, 3 more 1/10. So that made 12 tenths altogether. Fantastic. So did you find you needed to draw 2 holes and split both of those holes into 10 equal parts to make 12 tenths? What can you tell me about 12 tenths? Can you remember how we describe that, the terminology we can use to express it? Yes, I can hear you screaming at me. It's an improper fraction. Let's say this together. An improper fraction is when the numerator has a greater value than the denominator. Why does the numerator have a greater value than the denominator? It's because Because I've got more equal parts, haven't I? So I only needed 10 equal parts for my whole, because my whole is divided into 10 equal parts. We said that up here, didn't we? The whole is divided into 10 equal parts. But if I add on 3 more tenths, then actually now I have 12 tenths. So I have 2 extra tenths than 1 whole. Is there another way I can write that? So if I look at those wholes, I have 1 whole and 2 tenths. Really well done. And so this is described as a mixed number. Do you remember both those terms? Let's say it together. Mixed numbers are quantities made up of both whole numbers and fractional parts. So what's the same and what's different? Can you tell me what's the same and what's different? Pause me now. Have a little think about the different images we can see there. What did you think? What's the same? We've got the same number of equal parts altogether. So we've got 12 1/10ths altogether. Fantastic. What's different? The way we've written it, so the way we've expressed it. So here we've expressed it as an improper fraction, and we can see we've got 12 1/10ths, and here we've expressed those 12 1/10ths as wholes and parts, because we have 1 whole and 2 1/10ths as well. Excellent. We're going to continue looking at that now and thinking about the simplest form too. Let's have a look at counting in 3/10ths on a number line. Take a look at this number line. What can you tell me about the divisions? What do the divisions represent? So if we look at these yellow lines here, what are the divisions between those yellow markers? Yes, that's right, they are 1/10. Fantastic. So each of these divisions represents 1/10, because the whole has been divided into 10 equal parts. Really well done. Do you think you could show me with your finger where 3/10 is on this number line? Go on, put your finger at where you think 3/10 is. Did you say it was there? Excellent. So the whole has been divided into 10 equal parts, and 3 of those parts is represented by the numerator. And we can see there, can't we? 3 of those parts are shaded orange. Where would 6/10 be? So if I add on 3 more tenths now, where would 6/10 be? Can you show me where that is with your finger? So if I add 3/10, I would find that 6/10 is there. Is that where you got it? Fantastic. So 6/10, the whole has been divided into 10 equal parts, and 6 of those parts are represented by the numerator. Fantastic. And we can see, can't we, is that less than or greater than a half? It's greater than a half, isn't it? And we can see that more than half of the whole is shaded. And what would half of that whole be? It would be 5/10, wouldn't it? It would be 5/10 here. Excellent. And 5/10 is an equivalent fraction to a half. Okay, let's continue skip counting in 3/10. So 3/10 plus 3/10 is 6/10. Can you put your finger where you think the next fraction is going to come? The fraction, if I add on 3/10, will be there, 9/10. Fantastic. And that is, the whole is divided into 10 equal parts, and 9 of those parts are shaded and represented by the numerator. Have I got a whole yet? No. How many more parts do I need to make a whole? I need 1/10, don't I? And we can see that with that blue part that's not shaded there. So 9/10 plus another 10th would make 10/10, which is a whole. We're not going to add 1/10 though, are we? We're going to add another 3/10. Do you think you can put your finger where that will be and tell me how many tenths we have altogether? So 9/10 plus another 3/10 is 12/10. Fantastic. And so what do we call that? How did we express that? We said it was an improper fraction because the numerator is greater than the denominator. So the whole has been divided into 10 equal parts, which is represented by the denominator, but we have 12 of those parts. So we need 2 more parts. So the whole has been divided into 10 equal parts. 10 of those parts makes 1 whole. 2 more tenths gives us 1 whole and 2 tenths. And if I were to write it as 1 and 2 tenths, how would I be expressing it now? I'd be expressing it as a mixed number. So we can see, can't we, as an improper fraction, the numerator is greater than the denominator because I have more equal parts than 1 whole. And if I write it as a mixed number, I can say I have 1 whole and 2 tenths. Super. Now that you can tell me what an improper fraction is and show me what that looks like, we said we'd have a see if we could express that in its simplest form as well. Do you think we can? Let's have a see and revise how to find the simplest form. So how many tenths do we have altogether here? The sum of 3 tenths and 3 tenths is 6 tenths, well done. And how do we find the simplest form? We divide by the highest common factor, which is 2. Excellent. So our equivalent fraction is 3/5, because the numerator and denominator have been divided by the same common factor, and the highest common factor is 2, because 6 and 10, both the numerator and denominator, are in the 2 times tables, and 2 is a factor of both 6 and 10. Now, do you think we can apply that to this improper fraction? Can you find a common factor? Pause me now, have a see if you can find a common factor, and have a go at dividing the numerator and denominator by the same common factor and see what you get. I'll see you in a second. How did you get on? Did they have a common factor? Yes. What was the common factor? It's 2 again, isn't it? So if I divide the numerator and denominator by 2, what do I get? 6/5, really well done. And is 6/5 equivalent to 12 tenths? Yes, it is. But shall I have a look, see if we can prove that? So here we can say that that's the same as 1 1/5, because how many fifths did we need for a whole? We needed 5/5. And if we look at 1 1/5, would that be the same proportion of the whole as 12 tenths? Because each of these fifths here would be 2 tenths, wouldn't they? So I'd have 2, 4, 6, 8, 10, 12 tenths. Fantastic. Well done. You think you could do this one on your own? So if you can find the sum of 7 tenths and 8 tenths, I've put this number line here to help you so you can find out where 7 tenths is, add 8 tenths more, find out what the sum is, and then express it in its simplest form by dividing the numerator and denominator by the highest common factor. And see if you can go a little bit further and tell me what the mixed number would be. So pause me now, have a go at those and use the number line to help you. How did you get on? So what did you find was the sum of 7 tenths and 8 tenths? So if my unit is tenths and I've got 7 1/10ths and I add another 8 1/10ths, then I have 15 tenths altogether. Fantastic. Did you get that too? Really well done. So I wanted you to express this in its simplest form. What's the highest common factor of the numerator and denominator? It's 5. Well done, because 15 is a multiple of 5 and 10 is also a multiple of 5. So I can divide the numerator and denominator by the same highest common factor, which is 5. And what did you get as your equivalent fraction? 3/2. Fantastic. And it might help to have a think about that pizza now. If I look at a pizza and I cut it into halves, how many halves is 3/2? How many pizzas would I have? I would have 1 pizza and another half of a pizza. So sometimes thinking about the proportion of the whole helps us to express it as a mixed number, doesn't it? Because I've got 1 whole and 1 more half. Did you all get that? Excellent, really well done. Can you find the difference between 27/6 and 5/6? So quite a challenge for you here. I'm going to put a number line on to help you again. I want you to notice one thing. Where does my number line start? So it starts at 1 whole. It doesn't start at 0. So how many 6 do I already have? I already have 6 6. Really well done. So I want you to keep that in mind. And in finding the difference between these two fractions, you're going to have to show me where 27/6 is on the number line and subtract 5 of those 1 6. So pause me now and have a go at that, and then express your answer in the simplest form. How did you get on? Okay, where did you put 26/6? Did you put it here, 27/6? Did you put it there? Yes. Why did you put it there? We had to count up in 6 6, didn't we? So let's do that. 6 6, 12 6, 18 6, 24 6, and then 25, 26, 27 6. Fantastic. So we know we got that in the right place. And then I'm going to subtract 5, 6. And where did you put that? Yes, if I subtract 5, 6, I end up there, don't I, with 22, 6, which is between 24, 6 and 18, 6, which we counted before. Okay, how did you simplify it? Did you find the highest common factor of the numerator and the denominator? And what is that? It's 2 again, isn't it? Yes. So 22 and 6 are both in the 2 times tables. 2 is a factor of the numerator. So if I divide 22 by 2, I get 11. Well done. And 6 divided by 2 is 3. So I had 11 thirds. Where would that be on the number line? Where would it be on the number line? Where did you put it? Yes, it's in the same position as 22, 6, isn't it? Because they're equivalent fractions and they take up the same proportion of the whole. Do you think we could prove that? So could I write 11 thirds as a mixed number? How many thirds do I need to make a whole? 3 thirds, excellent. So 9 thirds would be 3 wholes and I have 2 more thirds. Excellent. Now, how can I prove that that's 3 and 2 thirds on the number line? So I've got 3 here. How can I split between 3 and 4 into thirds? Let's have a go. So 3 and 1/3 we can see there, can't we? 2 thirds, and that would be my third. So 11 thirds is in exactly the same place on the number line as 22, 6. So you have proven that those are equivalent too. As well as expressing it in its simplest form, which was 11 thirds, which is still an improper fraction, but then you went on to express that as a mixed number, which is a whole number and parts. Whew, that was an awful lot of work that we did there. So let's move on to our independent practice. We've worked really hard in that session and I think we've made an awful lot of connections. We've been really thinking about our understanding of improper fractions and mixed numbers and calculating and expressing the simplest form too. So I'd like you to apply what we've done to these 3 calculations. You've got 2 additions and a subtraction. And don't forget, you can draw number lines and express these pictorially to help you with your understanding. So I hope you've enjoyed today. You can look back at the generalisations to help you throughout the lesson and previous sessions, and we'll see you again. Bye. Goodbye.